Welcome to the Deep Dive.
Yeah.
Today, we're tackling Proxmox VE. Think of it as the ultimate open-source tool belt for your servers, handling both virtual machines, that's like running different computer systems within one way,
Right.
and containers, which are like super lightweight app environments. What's really powerful is that it's designed to grow with you. You know, whether you're just starting with a single server or managing a whole data center.
Exactly. And for you, our listener, who maybe wants to quickly grasp the essentials without getting lost in the weeds, we've gone through the massive Proxmox VE administration guide.
Yeah, it's pretty hefty.
It is. Our goal is to pull out the crucial insights, the things that will really give you a solid understanding of how this platform works and, well, why it's so compelling.
Our mission today is really to distill Proxmox VE down to its core strengths, those aha moments that make complex tech click. And one of the first things that just jumps out is how Proxmox VE rolls everything together. We're talking management, the actual virtualization tech itself, and even clustering capabilities, all built into one platform.
Right. Forget needing a separate server just to manage everything. That's a huge plus right there.
It really
It definitely simplifies things. So let's maybe start by looking at the central management, especially how it handles clustering.
Okay.
Proxmox VE has a built-in web interface. Imagine a single dashboard where you can see and control all your virtual machines, your containers, storage, and even your entire cluster if you have one.
Right, that single pane of glass view.
Exactly. It makes managing your infrastructure much more intuitive than, juggling multiple tools.
And here's where it gets really clever. It has this unique multi-master design. This means you can manage the entire cluster, all the servers working together from any one of those servers. That's pretty smart.
It is. And what makes this possible under the hood is the Proxmox Cluster File System, or PMXCS for short.
PMXCFS.
Okay. This is a really distinctive piece of technology, a special file system driven by a database that's specifically designed to store all the configuration files for your virtual machines and containers.
Okay, so all the settings for potentially thousands of VMs.
Yeah, think about it. The detailed settings all kept synchronized across your cluster.
How does it handle keeping all that data consistent then? That sounds like a lot to manage.
Well, that's where a technology called CoreSync comes in. PMXCFs uses CoreSync to replicate these config files in real time across all the servers in the cluster.
Right. Real-time replication.
Exactly. So if one server has an issue, the others still have all the latest configuration details. And while all this data is stored permanently on disk, the system also keeps a copy of the most important bits in the RAM of each server.
Wait, how much RAM are we talking about? Is it enough to handle configs for tons of VMs?
Surprisingly, yes. The in-RAM copy has a maximum size of just 30 megabytes.
30 megs. That sounds tiny.
It does, but the way PMXCS is engineered, it's more than enough to hold the essential configuration data for thousands of virtual machines. And here's a key insight. Proxmox VE is the only virtualization platform that uses this exact type of cluster file system. It's a really unique approach to managing distributed configurations.
That's a pretty significant differentiator.
Yeah.
Okay, let's switch gears a bit and talk about the philosophy behind Proxmox VE. It's open source, right? What does that really mean in practice?
Absolutely. It's built on the fundamental components of the Linux kernel, the core of many operating systems, and the Debian GNU Linux distribution, which is, known for its stability and wide range of software.
Right. Debian's solid.
Very. And the entire source code for Proxmox VE is released under the GNU Afro General Public License version 3. This isn't just a formality. It's a deep commitment to transparency.
So what's the real benefit for you, the listener? Why should you care that it's open source?
Well, it gives you a huge amount of freedom. You can actually look at the code yourself to see exactly how it works, which can be a big plus for security.
Transparency.
Exactly. You also have the option to modify it to fit your specific needs, and if you have the expertise, you can even contribute those changes back to the project for everyone to benefit from.
Right, the community aspect.
Precisely. The core idea is that being open source ensures full access to all the features, leading to strong security and reliability because the code is constantly being reviewed by a large community. It puts you in control rather than being tied to some closed proprietary system.
It makes a lot of sense. It's about controlling community. Now, let's say you're on board and want to install Proxmox VE. What does that process look like? Is it difficult?
No, it's designed to be quite user-friendly, actually. Proxmox provides ISO image files. These are like digital copies of an installation DVD or USB drive.
Standard ISOs, okay.
Yeah. These images contain a complete Debian system along with all the Proxmox VE software needed to get started. The installer walks you through the whole process step by step.
Like partitioning and basic settings.
Exactly. Setting up your hard drives, basic system settings like your time zone, language, network connections. The whole thing should only take a few minutes, really.
Wow, okay.
Using this ISO image is the recommended approach, whether you're setting up a brand new server or upgrading an existing one.
Any specific hardware considerations we should keep in mind before diving in?
Yes, a few key things. For your network, having redundant multi-gigabit network interface cards, or NICs, is highly recommended.
Especially for clusters, I imagine.
Oh, absolutely. Especially if you're planning on using advanced features or running a lot of virtual machines. You might also need more NICs depending on your chosen storage technology and, yeah, whether you're building a cluster.
Made sense.
Also, if you want to directly assign physical hardware devices like a graphics card to your virtual machines, this is called PCIe, pass-through.
Yeah, for things like GPU acceleration.
Right. Your CPU needs to support a specific feature, VTD for Intel processors or AMDV for AMD processors. Without this, you won't be able to directly give a VM access to physical hardware.
Got it. So VTD or AMDV, that's the key flag there. Before getting too deep, is there a quick way to get a sense of how your hardware will perform with Proxmox VE?
Yeah, Proxmox VE includes a handy command line tool called pverper.
pverper, okay.
Running this will give you a general idea of your CPU and hard disk performance on the system where you've installed it.
Just a baseline, though.
Exactly. It's important to remember that this is just a quick initial check. For a more thorough understanding of how your storage will handle the demands of VMs and containers, especially its input-output performance, or I/O, more detailed testing is always a good idea.
Okay. What if someone runs into a problem during the installation itself, like graphics issues, any quick troubleshooting tips?
Yeah, that can happen. If you're using the text-based installer and you encounter issues with the graphics display, a common workaround is to use the nomodset kernel parameter.
Nomodset, how do you use that?
During the boot process, you can usually access a menu where you select the Install Proxmox VE Terminal UI option. If you edit that entry, you can add nomodset to the line that starts with the word Linux.
Oh, okay.
This often helps resolve display problems caused by graphics drivers during the initial installation. Think of it as a sort of safe mode for your display during setup.
That's a useful trick to have in your back pocket.
Yeah.
And what about for those who want to automate the whole installation process, maybe for multiple servers?
Proxmox VE does support unattended installation. This allows you to completely automate the setup of Proxmox VE on a bare metal server without needing to manually answer prompts.
Using an answer file.
Exactly. You create a configuration file beforehand, and the installer reads from that file. Once the installation is finished and the server reboots, you can then use automation tools like Ansible to further configure the system to your exact specifications.
Nice. Okay, so you've got Proxmox VE installed. How does it handle software updates and getting access to new features? That's where software repositories come in, right?
Precisely. Proxmox VE uses the standard Debian package management system, which relies on software repositories. Think of them as online libraries of software packages.
Right, APT repositories.
Yep. Proxmox VE has a few different repositories tailored to different needs. The Paradis repository, as the name implies, contains the very latest packages, including new features that are still being tested.
So bleeding edge stuff.
Pretty much. This is mainly intended for developers and those who want to try out the newest things. You enable it by adding a specific line to the etcapsources.list file. Just be aware that software in this repository might not be as stable as the packages in the more official ones.
Makes sense. What about updates that are more production ready, especially for things like Ceph?
Right. For stable versions of Ceph specifically, versions like Squid and Reef Proxmox VE provides enterprise repositories.
Okay.
These are recommended for production environments if you are using Ceph clients or running a full Ceph cluster on your Proxmox VE nodes. There are also test repositories for pre-release versions of Ceph packages if you want to get an early look at what's coming.
And you manage those separately?
Yeah, you add these Ceph-specific repositories to a separate file located at etcapsources.list.dcf.list. This keeps the core Proxmox VE updates separate from the Ceph updates.
Gotcha. Moving beyond the core OS, what about the low-level software embedded in the hardware itself, the firmware? Can Proxmox VE help keep that up to date?
Somewhat. Proxmox VE does have some capabilities for this. It supports runtime firmware updates for certain peripheral devices like network cards and graphics cards.
So update while the system's running.
Potentially, yes. But it's important to understand that Proxmox VE doesn't directly handle updating the firmware that's stored on the motherboard itself, the BIOS or UEFI, or the firmware of hard disks or SSDs.
Right, that's usually vendor tools.
Exactly. Those typically require separate tools provided by the hardware manufacturers.
How can you even check what firmware versions you're currently running on your system?
I see.
For the CPU microcode.
Right. For the CPU microcode, which is a very low-level piece of software that can impact stability and performance, you can check the currently running revision using the command grep microcode proc.info unique.
Okay.
And if you've installed a new microcode package and you see a message in your system log that says microcode updated early, it basically means that the system loaded a newer version of the microcode during boot than what was originally embedded in either the CPU itself or the motherboard's firmware.
Ah, interesting. So it applied an update on boot.
Pretty much.
Okay, let's talk networking, a fundamental aspect of any server setup. How do you configure network interfaces in Proxmox VE? Is it just standard Linux stuff?
Mostly, yes. The primary way to manually configure your network settings in Proxmox VE is by directly editing the etc network interfaces file.
Okay, the standard interfaces file.
Right. This is where you define your network interfaces, IP addresses, gateways, all that. After you make any changes to this file, you can apply them without needing to reboot your entire server by running the command iforload A.
iforload A. Useful.
Very. Now, if you're upgrading from an older version of Proxmox VE, or if you installed Proxmox VE on top of an existing Debian system, it's crucial to make sure that a package called ifupdown2 is installed.
ifupdown2. Why is that important?
That's the modern way Proxmox VE manages networking and allows things like iforload to work properly.
Got it. What if you do reboot the server? Will it still apply the network configuration from that file?
Yes, it will. Proxmox VE uses a system service, a background process called pedvenit commit. Right. This service takes the network configuration you've defined and ensures it's applied correctly during the boot up sequence. It essentially prepares a temporary network setup before the main networking services fully come online.
Okay. Network interface names can sometimes be a bit confusing, ETH or AP30 or whatever. How does Proxmox VE handle these? And can they change unexpectedly, like after an upgrade?
Yeah, the naming can follow various schemes. Onboard cards might be an O1, PCI cards NP3, FU, F1, that kind of thing. The systemd.net naming scheme man page explains all the patterns.
Right.
But yes, one important thing to be aware of is that major upgrades to systems, which can happen during a Proxmox VE upgrade, can sometimes introduce new versions of these naming schemes.
Ah, so your 8th year might suddenly become NP0.
Exactly, which can break your configuration. To prevent this, you can manually pin your system to a specific version of the naming scheme. You can also use what are called link files, described in the systemd.link5man page, to create consistent and predictable names for your network interfaces, regardless of the underlying hardware or naming scheme version.
That sounds useful for stability. So what are the fundamental ways you can set up networking for your virtual machines and containers in Proxmox VE?
There are 3 main network configuration models to choose from, depending on your network setup and what you need your guests to do. Bridged, routed, and masquerading.
Okay, let's start with bridged. That sounds like the most common.
It is. The bridged model is the default and often the most straightforward, especially for servers on a private LAN. In this setup, your VMs and containers appear as if they are directly connected to the same physical network switch as your Proxmox VE host.
So they get their own IPs on the main network.
Exactly. They did their own IP addresses from your network's DHCP server, or you can assign them static IPs within your LAN's range. They're basically just another device on the network.
And how is this bridge typically set up in Proxmox VE?
During installation, Proxmox VE automatically creates a default network bridge named VMBRE0 and connects it to your first physical Ethernet card.
Ah, VMBRE.
Yep. You can see an example of this default configuration and modify it in the accept network interfaces file.
What about the other options, routed and masquerading? When would you use those?
Okay, so masquerading, which is also known as network address translation, or NAT.
NAT, right.
That's particularly useful when your VMs or containers only have private IP addresses, so they're not directly reachable from the outside, but they still need to access the internet.
Like a typical home router setup.
Kind of, yeah. The Proxmox VE host acts as a gateway. All the outgoing traffic from your guests appears to originate from the host's IP address. This is typically configured using the Linux firewall tool iptables.
Okay.
The docs have examples, and they mention that in some complex setups, especially with other firewalls, you might need to configure something called contract zones.
And route.
The routed configuration is more advanced. You manually set up routing rules on your network to direct traffic to and from your virtual guests. It gives you more control, but needs a deeper understanding of network routing.
Gotcha. What if you want to improve the reliability and the speed of your network connection for the Proxmox VE host itself?
That's where network bonding comes in, or link aggregation.
Right, combining multiple physical NICs.
Exactly. You take multiple physical network interfaces and combine them into a single logical interface. This not only increases the total bandwidth available, but also provides fault tolerance.
So if one link fails, the others keep going.
Precisely. The Proxmox VE documentation shows how to configure a bond with a fixed IP. And importantly, it also shows how you can then use this bonded interface as a port on your network bridge, like VMware 0.
Oh, so the guests benefit too.
Yes. It extends that increased reliability and bandwidth to all your VMs and containers connected to that bridge. So if one physical link in the bond fails, your guest's network connectivity ideally remains unaffected.
That's pretty cool. Let's move on to the crucial topic of storage. How does Proxmox VE manage the underlying storage where your VMs and containers actually live?
Okay, so the default installation of Proxmox VE uses a technology called Logical Volume Manager, or LVM.
LVM, standard Linux stuff.
Right. It uses LVM on the hard drive or SSD you select during the initial setup. This creates a container for your storage called a volume group, which is typically named PVE.
Okay.
You can get a basic overview using command line tools like PVS for physical volumes and VGs for volume groups.
LVM is flexible, but Proxmox also integrates really well with ZFS, right?
Yeah.
Which is more advanced.
Absolutely. ZFS offers features like built-in RAID, snapshots, data integrity checks. It's very powerful. Now, when you're considering ZFS for RAID,
Redundant array of independent disks.
right, it's important to understand how usable space is calculated in RAID Z configurations, like RAID Z1, Z2, Z3. Generally, usable space is total capacity minus parity space.
So a 4-disk RAID Z2 loses 2 disks worth of capacity for redundancy.
Correct. Interestingly, for many virtual machine workloads, using mirrored pairs like RAID 1 or RAID 10 might actually give you better performance, especially IOPS, while providing the same amount of usable space as some RAID setups on the same number of disks.
Okay, so mirror's often better for VMs then.
Often, yes. Unless you have specific needs like massive sequential throughput. Now, about ZVLs.
Right, I see that term used for storing VM disk images.
Yes, ZVLs are essentially block devices created within a ZFS pool for virtual hard disks. When you write data to a ZVL in a RAID Z array, ZFS also writes parity info across other disks.
Okay.
This process is influenced by the shift value of the pool, which defines the smallest block size. If the ZVL's block size is larger than a shift, it can sometimes lead to writing more parity than necessary, impacting performance.
And a shift. You need to set that carefully.
Critically important. You must avoid setting a shift 9 when creating a pool.
Why?
It's a small block size that severely limits performance on modern drives, and you cannot change it later.
Ouch. Okay, avoid a shift 9.
Definitely. For most VM workloads, mirrored VDEVs like RAID 1 or RAID 10 often provide more consistent and higher performance.
I noticed a term called DRAID in the ZFS documentation. What's the benefit of that compared to traditional RAID?
ZFS trade, declustered RAID. It's an interesting, more advanced feature. In traditional RAID with hot spares, the spares just sit idle.
Right, waiting for a failure.
With DRAID, this spare capacity is integrated into the RAID layout from the start. This allows for significantly faster rebuilding if a drive fails, because the data can be rebuilt across more disks simultaneously, including what would normally be the idle spare.
So faster recovery times for large arrays.
Exactly. The OpenZFS docs have more detail. It's aimed at improving resilience, especially for large pools.
How does Proxmox VE handle the bootloader, the software that starts the OS, when you're using ZFS as your storage?
Yeah.
It used to be tricky.
Yeah, Proxmox VE uses a specific tool for this called Proxmox Boot Tool.
Proxmox Boot Tool, okay.
This tool manages the bootloader configuration on your ZFS root file system.
Okay, so you've chosen ZFS. What are some common day-to-day management tasks you might perform?
Well, the primary tools are the command line utilities ZS and zpool. Both have really good man pages, manzus, manzpool.
Right.
To create a new pool, you use zpool create, you specify disks, and you really need to consider that a shift value, ensuring it matches or exceeds your disk sector size.
Got it.
The docs give examples for creating mirrors, RAID 1, RAID 10, RAID 1, RAID Z2. It emphasizes thinking about your expected IOPS and bandwidth needs before choosing a RAID Z level.
What about improving the performance of an existing ZFS pool after it's already set up? Can you add caches?
Yes, definitely. You can significantly improve performance by adding cache devices, usually fast SSDs for read operations. This is the L2ARC. And you can add log devices, also fast SSDs or NVMe drives, to accelerate synchronous writes. This is the ZAL, or ZFS intent log.
Okay, ZL provides L2ARC for how big should the ZL be?
The general recommendation for the log device ZIL is about half the size of your server's installed RAM.
Half the RAM size for the ZFS.
Hello.
Got it. Can you control how much of your system's memory ZFS uses for its main cache, the IRC? It can use a lot, right?
It can, yeah. But you have fine-grained control. You can limit the maximum and minimum RAM ZFS uses for its adaptive replacement cache, ARC, by adjusting the kernel parameters ZFSarcMax and ZSarcMin.
Okay.
If your root file system is on ZFS, after changing these, you'll need to update your initrams and reboot for the changes to take effect.
I saw a note about using swap space on ZFS. Is that something to be cautious about?
Yes, it is. Creating swap space on a ZFS ZVOL can sometimes lead to performance issues, like the server becoming unresponsive or having very high I/O load, especially during backups.
So generally avoid swap on ZFS.
Many ZFS experts recommend against it. If you do choose to have swap on ZFS, you might want to consider adjusting the kernel parameter vm.swappiness. This controls how aggressively the kernel swaps things out. The docs have a table explaining different swappiness values.
Okay. Are there any experimental ZFS features in Proxmox VE that users should be aware of?
Yes, native ZFS encryption is currently considered experimental.
Encryption built in. Nice, but experimental.
Right. While it allows you to encrypt datasets, there are known limitations. Replicating encrypted datasets might not always work as expected, and there have been reports of potential checksum errors with snapshots or ZVOLs when using encryption. The docs usually link to bug reports for details on experimental stuff.
Good to know. What if you want to turn off ZFS compression for a specific dataset? Maybe it's already compressed data.
Easy enough. You use ZFS set compression off, followed by the dataset name.
Okay.
Just remember, this only affects new data written after you run the command. Anything already compressed stays compressed.
The term ZFS special device came up. What exactly is the purpose of that? Sounds special.
Yeah. Since ZFS 0.8.0, you can designate certain devices, typically very fast SSDs or NVMe drives, as special devices within a pool. Their main job is to store metadata.
Metadata, like file names and directory info.
Exactly. File names, directory structures, permissions, that sort of thing. By putting this metadata on faster storage, you can significantly speed up pools made mostly of slower spinning disks, especially for workloads with lots of metadata operations, like creating or deleting many small files.
So it accelerates metadata-heavy tasks.
Right. And you can even configure datasets to store entire small files on the special device too, further boosting performance for certain data types.
You mentioned RAID levels earlier. Just to recap quickly, RAID 1 and RAID 10.
Sure. RAID 1 is mirroring. Minimum 2 disks. Data is copied exactly to both. If one fails, the other has the data. Usable capacity is the size of one disk.
Okay, simple mirroring.
RAID 10, or RAID 1 plus 0, combines striping, RAID, and mirroring, RAID 1. Minimum 4 disks. Disks are mirrored in pairs first, then those pairs are striped together.
So you get redundancy and speed increase.
Correct. Usable capacity is typically half the total capacity of all disks.
What about BTRFS? Is that also a supported file system in Proxmox VE? Seems less common than ZFS.
It is supported, yes. If you choose BTRFS during installation, it creates a subvolume at varlib balical BTRFs and adds a corresponding storage entry in xzpvstorage.cfg.
Okay. How does it differ from just using a directory for storage?
The key difference is that raw disk images for VMs and containers are placed within BTRFS subvolumes. This allows you to use BTRFS's snapshot capabilities effectively for backups and also enables offline storage migration while preserving those snapshots.
So subvolumes enable snapshotting.
Exactly. It's also worth noting BTRFS respects the ODirect flag, which bypasses the OS cache, so it's generally advised not to use the none cache mode for VMs stored on BTRFS.
Got it. Okay, we've covered a lot about storage. Let's shift focus to managing the Proxmox VE servers themselves, the nodes. Are there any useful node-level configurations?
Absolutely. For example, you can configure wake on LAN, Womble, for a specific node using pvnode config set. You need the MASI address, obviously.
Wake on LAN, handy. What about seeing what's happened on a node? Task history.
Yep. The The bufnode task command is invaluable for that. It lets you access a history of all the tasks run on that particular server. Great for troubleshooting.
Security is always key. How does Proxmox VE help with managing TLS certificates, like for the web GUI using HTTPS?
Proxmox VE has excellent built-in support for ACME.
ACME,
Like
let's encrypt.
Exactly. Let's Encrypt is the most popular ACME implementation, providing free TLS certificates. You can manage this directly from the command line using pvnode acme.
Oh, cool.
You can set the domain, choose a challenge plugin like DNS validation, and order and install the certificate. Makes securing the web interface much easier.
Nice. And what about managing the underlying bootloaders, especially with things like Secure Boot becoming more common?
Right. Proxmox VE uses that Proxmox boot tool we mentioned earlier, especially for ZFS root setups. It can sync the EFI system partitions, ESPs, across multiple disks for redundancy.
So you can boot even if one boot disk fails.
Ideally, yes. It also helps migrate from the default system boot to GRUB, considering secure boot requirements. You use Proxmox boot tool init for setup or conversion. You can even keep system boot as a fallback.
For those needing custom kernel modules, maybe for specific hardware, how does Proxmox VE handle signing them for secure boot?
It integrates seamlessly with DKMS dynamic kernel module support.
DKMS, right. That rebuilds modules on kernel updates.
Correct. Proxmox extends this by allowing DKMS to automatically generate a key pair and certificate and then use that cert to sign the modules it builds.
Okay, so the modules get signed. How does secure boot trust them?
You need to enroll that signing certificate into your system's UEFI firmware using a tool called mokutil with the import command. You'll usually be prompted to complete this MOK, machine owner key enrollment, during the next reboot.
Gotcha. Enroll the MOK. Finally, on node management, what about kernel same-page merging, or KSM? Is that something someone might want to adjust?
KSM is a Linux kernel feature that can save memory by merging identical memory pages across different processes or VMs.
Deduplication for RAM, basically.
Kind of, yeah. You can check if it's active with systemtil status salestuned. The sessuntune service does the scanning and merging.
Why would you disable it?
In some specific scenarios, you might suspect it's causing performance issues with certain workloads. You can disable it immediately using systemtil disable, now sessuntuned. You can also force it to unmerge already merged pages if needed.
Okay. Let's switch our attention to how you actually interact with Proxmox VE day to day. What's the user experience like? The GAI.
The primary way is through its web-based graphical user interface. It's designed to be pretty intuitive, accessible via modern browsers like Firefox or Chrome.
And it has a built-in console.
Yes, an HTML5 console, so you can access VM or container terminals directly in the browser. For VMs, it also offers Spicy as an alternative, which can be better for graphics-heavy stuff.
Can you customize the look and feel of this web interface much?
To some extent, you can customize the main dashboard view, and within the built-in console, it uses scrim.js, you can adjust things like font family, size, letter spacing, line height, make it more comfortable.
How do you navigate through all the different parts, VMs, containers, storage nodes?
It uses a resource tree on the left-hand side. The default is server view, which gives a hierarchical layout. You can choose other views to organize things differently if you prefer.
Okay, standard tree view. Once you select something in the tree, what options do you see?
The main right-hand panel changes based on what you selected. For a VM or container, you'll usually see tabs. Summary gives an overview and has a notes field.
Notes field. Can you format text there?
Yes. It supports Markdown for formatting. Very handy.
Cool. What other tabs?
You'll have console, hardware or resources for settings, network, DNS for containers, options, task history, then extras depending on VM or container. VMs often have a KVM monitor, backup, replication, snapshots, firewall, permissions.
So quite a lot of specific controls per object. What about managing storage through the web interface?
Similar layout. A left-hand menu lists your configured storages. Select one, and the right panel shows tools and info for that storage view contents, create volumes, adjust settings, etc.
I noticed the documentation mentions tags. What are those used for within Proxmox VE? Just labels?
Pretty much. Tags are a way to add descriptive labels or metadata to objects like VMs, containers, storage. You can manage how tags behave globally under data center options.
How so?
You can set the mode list, only predefined tags allowed. Existing, use existing or add new ones, or none, no tags. Users with sysmodify privilege can always manage any tags, though. There's also a concept of registered tags for more control scenarios.
Okay, flexible tagging. Proxmox VE is well known for clustering. Let's delve into that. What are the fundamental aspects? What makes it tick?
At its core, a Proxmox VE cluster relies on a technology called CoreSync.
CoreSync, there.
This provides the low-level communication backbone, keeping all the server's nodes in sync and letting them make decisions together. Now, CoreSync doesn't need huge bandwidth, but it is very sensitive to latency network delay and packets per second.
So a fast, low-latency network is important for the cluster interconnect.
Very important. If you have multiple Proxmox clusters on the same physical network, they could potentially compete for resources, so separate networks are often better for larger setups.
How do you actually go about adding a new server, a new node to an existing cluster?
Okay, when you add a node, its existing configuration, etc. EV gets completely overwritten by the cluster's configuration.
Ah, okay, so the joining node needs to be clean.
Pretty much. It cannot have any existing VMs or containers because their IDs might conflict with the cluster.
Yeah.
The usual workaround is back up anything on the node, join it to the cluster, then restore the backups, maybe with new IDs. The joining node also inherits the cluster's storage config. So if it had different local storage, you'll need to re-add that within the cluster settings and adjust node restrictions if needed.
How do you actually do the join command line?
Easiest way is usually via SSH. Log into the node you want to add and run pvscer add p address cluster using the IP of any healthy node already in the cluster.
PSEM add.
Yeah.
Okay. And check status with.
pvsem status from any node.
What if you need to remove a node from a cluster? Say, decommissioning a server. Any gotchas?
Yes, removing requires care, especially if that node was part of a Ceph storage setup.
Right, Ceph depends on multiple nodes.
Exactly. You need to ensure enough remaining nodes still have Ceph OSDs, the data daemons, to maintain redundancy. The docs outline specific steps for removing Ceph nodes, checking monitors, managers, etc.
Okay, and the command to actually remove it?
The command is pvsem del node, followed by the host name of the node to remove.
Proxmox VE offers redundancy for that CoreSync network communication itself, right? To make the cluster more resilient.
Yes. CoreSync has an integrated networking layer called ChronosNet that allows redundant links. You can specify multiple network addresses for CoreSync to use, either using linkx parameters with pvsem when creating gadding, or by manually adding multiple ringexadder entries in coresync.conf on each node.
And ideally, these links use separate physical networks.
For true failover, yes. Each link should use its own physical connection. The system uses them based on priority, netlink priority, or priority with pvsem. You can test a new link by unplugging an old one and checking pvsem status.
What role does SSH play within a cluster? Is it just for logging in?
SSH is crucial. It's used for various internode tasks, allowing secure command execution across nodes. But a potential issue, automatic execution of shell configs like .bashrc on SSH login. It's recommended to add a check in your shell config so commands only run in interactive sessions, preventing weirdness when Proxmox uses SSH in the background.
Good tip. I came across something called a Q device in the context of clusters. What's its purpose? Sounds like quorum related.
Exactly. For a cluster to work, it needs quorum a majority of voting nodes online. A Q device is an external witness that provides an additional vote in the quorum calculation.
Why would you need that?
It's particularly useful in clusters with an even number of nodes. Adding a Q device gives the cluster an odd number of votes, which helps prevent split-brain scenarios where isolated halves of the cluster make conflicting decisions.
The tiebreaker. How do you set it up?
You use pvsabm device setup and check its status with pvsam device status. The status shows flags indicating its state and contribution to quorum.
When you're moving virtual machines between servers, migrating them, does that traffic go over the same cluster network?
By default, yes. Both live and offline migration traffic uses the same network as CoreSync.
That sounds like it could cause problems if you're migrating a big VM.
It can. Migration traffic, especially live migration copying RAM, can be bandwidth heavy and might interfere with that latency-sensitive cluster communication.
So can you separate it?
Yes. Proxmox lets you configure a dedicated migration network. You set this parameter with a network CIDR, like 192.168.men0024. All migration traffic memory for live, storage for offline will then use this separate network.
That's much better for performance and stability. What happens if a node in the cluster fails suddenly? Can you recover the VMs that were on it?
In certain advanced situations, you might be able to manually recover a VM by moving its config file from the failed node's config directory to a healthy node's directory.
But that sounds risky.
Extremely. It comes with a critical warning. The source node must be completely powered off or successfully fenced, isolated, before you try this. Otherwise, you risk violating locking mechanisms and corrupting data.
Okay, very dangerous.
And it has limitations. It generally won't work for VMs with disks on local storage of the failed node. In most cases of node failure, you either wait for repair or restore from backups onto a healthy node. Manual recovery is a last resort.
Let's explore the different types of storage backends Proxmox VE works with in more detail. Seems like there's a huge range of options.
You're absolutely right. It's very flexible. The docs have a big table listing them all network options like NFS, CIF SSMB, Proxmox Backup Server, Gluster FS,
Does it SF?
block storage, LVM, LVM thin, various ISCSI options, kernel and user mode, Ceph RBD, ZFS over ISCSI, and just local directory storage too. The table shows if they're file block, shared, support snapshot, support clones. It's a good overview.
Can you highlight key characteristics of a few common ones? Like NFS.
Sure. NFS is file-based, easily shared. A nice thing in Proxmox is you configure the NFS server details in the GUI, no need to manually edit, etc. stab on each node. It has tools to test connectivity and query exported shares too.
Okay. What about ZFS as a storage backend?
ZFS is block level, powerful, integrated snapshots, thin clones. You manage it with ZFS create, ZFS X set compression on, and Belezim scan ZS helps Proxmox see it.
LVM, the default.
LVM is block level, often seen as simpler for basic disk management, useful on top of ISCSI LUNs. Standard LVM in Proxmox doesn't do snapshots or clones efficiently like ZFS though. There's an option safer move throughput for controlling thin LVM discard speed.
ISCSI.
ISCSI is block level, network storage presented as local disks, PSM scan is ProfSC finds targets. There's also a user mode version, is Booty Direct.
Who's FS?
CephFS is a distributed file system on top of Ceph, shared PSX compliant. Experimental snapshot support in Proxmox, no clones currently. Needs a keyring file for authentication with external clusters.
And BTRFS.
BTRFS is kind of like directory storage, but it puts VM container disk images in subvolumes. This enables BTRFS snapshots and offline migration preserving snapshots. Remember, it honors ODirect, so avoid none cache mode for VMs on it.
What about thin provisioning? That sounds useful for saving space.
It is. Thin provisioning is supported by several storage types, like LVM thin, ZFS, Ceph RBD, and also by the Cow2 image format. It means storage space is only allocated when data is actually written by the guest OS.
So a 100 GB virtual disk might only use 20 GB on the actual storage if that's all the guest OS is used.
Exactly. Allows you to over-provision virtual disk sizes and add physical capacity later as needed without resizing guest file systems. Are there common storage properties you configure across different types in Proxmox?
Yes, a few common ones. The nodes property lets you restrict which cluster nodes can use a specific storage, useful for local storage.
Right.
The content property defines what types of data the storage holds. Disk images, ISOs, container templates, container root odors. Not all storage types support all content types, obviously. You wouldn't put ISOs on block storage.
How can you find out the actual file system path where a virtual disk image is stored?
You use PAVSM path, followed by the storage ID and the volume ID, like VM100, disk 0. It gives you the full path.
And freeing up unused disk images?
PAVSM free, followed by the volume ID.
Ceph seems really deeply integrated.
Yeah.
What are the main advantages of using Ceph with Proxmox VE?
Oh, loads. Easy setup and management via GUI CLI. Thin provisioning, snapshots, self-healing from failures, highly scalable, unified storage block, file, object, flexible pools for different needs, fault tolerance via replication, runs on commodity hardware, no expensive SAN needed. And it's open source, like Proxmox.
Can you run Ceph on the Proxmox nodes themselves, hyper-converged?
Yes, absolutely. For small to medium setups, you can install Ceph server components directly on Proxmox nodes, creating a hyper-converged infrastructure. Compute and storage tightly integrated. Proxmox has native tools, SF, and GUI integration for this.
Are there specific resource considerations CPU memory when running Ceph hyper-converged?
Yes, definitely. Ceph OSD CPU usage depends a lot on the underlying disk IOPS. Fast SSD SNVM drives can use multiple CPU threads per OSD.
All right.
And careful memory planning is crucial. You need enough RAM for your VM's containers and for Ceph to operate efficiently. Skimping on RAM for Ceph leads to bad performance.
How do you actually go about creating a Ceph cluster within Proxmox?
First step is usually initializing the first monitor. Monitors maintain the cluster map. The docs guide you through this, typically picking one node for the initial monitor.
Then add the storage disks.
OSDs.
Right. You add OSDs, object storage devices, using Hypervisor, and you create. This command has options like specifying dedicated devices for the OSD's journal, WAL, and its metadata database, DB. Use fast SSDs for DB wall.
Highly recommended, yes. Fast SSDs or NVRAM for DB wall significantly boosts performance, especially for writes. Proxmox also has commands to stop, FSF stop, destroy, SFSD destroy cleanup, and remove OSDs when needed.
What about Ceph pools? How are those managed?
Ceph pools are logical groups where data objects are stored. Each pool is divided into placement groups, PGs, internally for distribution and redundancy.
Okay.
You create pools via GUI or VSF pool create set. You define replica count, how many copies for fault tolerance, and minimum replicas needed for writes, min size. Setting min size to 1 is strongly discouraged risk of data loss.
How do you choose the number of PGs?
Getting the PG count right is important for performance. It's recommended to either enable the PG autoscaler, which adjusts it automatically, or manually calculate it based on cluster size and expected object count.
Yeah.
Since Ceph Nautilus, you can change the PG count after creation, which is helpful.
If someone already has an external Ceph cluster, can they just connect Proxmox VE to it?
Yes, absolutely. You configure a new CephFS or RBD storage entry in Proxmox, giving the monitor IP SHOS names. If the external cluster uses suffix authentication, the default, you need to copy the client's secret keyring file from the Ceph cluster to etc.privé priv ceph on your Proxmox nodes. The file name usually matches the storage ID. This lets Proxmox authenticate.
What about managing CephFS itself from Proxmox?
Proxmox provides basic management, creating and destroying CephFS file systems via GUI CLI. But destroying a CephFS makes all its data unusable and is usually irreversible.
So be careful.
Very. The docs outline a multi-step process for removal. Disconnect clients, disable storage entries, remove resources on the CephFS, unmount it everywhere, and then use Ceph commands to remove it from the Ceph cluster itself. It's involved.
High availability, or HA, is critical for production. How does Proxmox VE implement HA for VMs and containers?
Proxmox has integrated HA through its High Manager service. The goal is minimizing downtime by detecting node failures and automatically restarting failed guests on other healthy nodes with resources.
Sounds good, but are there trade-offs?
Yes, HA adds complexity and usually requires redundant hardware and careful planning. The docs mention that with typical failover times, 1 to 2 mins, you might achieve up to 99.999%, 5 nines, availability, theoretically.
What are the different states an HA resource like a VM managed by HA can be in?
Several states. Started running, stopped, intentionally stopped, migrated, live migrated, ignored, temporarily ignored by HA manager. Error, local manager failed, needs manual check. Queued, newly added, not yet processed, and disabled. HA turned off for this resource.
What are the main software components making HA work?
2 key parts. First, the local resource manager, PVE Hall RMM, runs on every node, starts after quorum is achieved, manages local HA services, and carries out orders.
Okay, the local agent.
Right. Second is the cluster resource manager, or CRM. This is the central decision maker. It decides where when HA services should start, stop, migrate based on cluster state and policies. CRM decides, LRMs execute. The CRM itself can be waiting, active, or have lost its lock, indicating a problem.
Is there any hardware component that can significantly enhance HA reliability, like preventing hangs?
Yes, configuring a hardware watchdog timer. By default, Linux kernel watchdog modules are often blocked. You need to specify the module name, like itcow and etc. Default PVHAM manager, the watchdog mux service, loads it.
And the watchdog reboots the server if it hangs.
Exactly. It's an automated way to recover from certain types of node unresponsiveness, crucial for HA.
What happens to the VM's containers on a node if it suddenly fails and gets fenced, isolated?
If a node fails and is successfully fenced, the CRM detects it. Based on the HA configuration for the guests on that failed node, the CRM will attempt to move those services to other healthy available nodes with sufficient resources.
What about shutting down a node gracefully? Can HA influence that, like migrate things off first?
Yes, you can configure a shutdown policy. A common option is migrate. When enabled, initiating shutdown on a node makes its LRM mark itself unavailable. This triggers the CRM to migrate HA manage guests off that node to others. Once they're moved, the shutdown proceeds.
Assuming they can be migrated.
Right. If they have local disk dependencies, it might not work automatically. You configure this policy globally in Data Center Options, Deck HA Settings, or datacenter.cfg.
Can you manually move HA resources between nodes, say for maintenance?
Yes, absolutely. You can manually migrate HA-managed VMs containers using the GUI or CLI, useful for maintenance or rebalancing.
Important warning, though.
Critically important. Do not forcefully kill Neck9 the HA services like PVHA or harem, PVHAR, or Watchdog Mux. This can cause an immediate node reboot or reset, disrupting HA.
Proxmox also has a setting for cluster resource scheduling mode. How does that interact with HA?
CRS mode influences how HA chooses nodes for recovery after failure and also for migrations triggered by shutdown policies. The default is basic. Different modes might use different strategies based on resource use or preferences, configurable in GUI or datacenter.cfg.
Backups are absolutely essential. What backup restore capabilities are built into Proxmox VE?
Proxmox offers a fully integrated backup solution. Works across various storage types for both VMs and containers. Backups are always full backups config and all data,
How do you run them?
either through the web GUI or using the vzdump command line tool.
What are the different backup modes available specifically for containers? LXC.
3 main modes for containers: stop, container shutdown first; suspend, state pause to disk, potentially faster backup restore; and snapshot.
Snapshot mode depends on storage.
Yes, snapshot mode is only available if the container's root file system is on storage that supports snapshots, like ZFS, BTRFS, LVM, Thin, Ceph. It's often very quick and efficient.
What about virtual machines? Can you do live backups while they're running?
Yes, Proxmox offers live backup for QEMU server VMs. It provides snapshot-like semantics even if the underlying storage doesn't support snapshots natively.
Any quirks with live backup?
One minor thing. During a live backup of a stopped VM, it might briefly appear as running in the GUI while QEMU reads its disk data. But the VM itself isn't actually booting up.
I saw the term fleecing mentioned with backups. What does that mean?
Fleecing is a technique to help ensure application consistency inside the guest, especially for Windows or apps with data in memory. It tries to quiesce the file system and I/O before the backup starts.
Does it have requirements?
Yes. It typically requires fast local storage that supports thin provisioning and discard. Tryman map. You can enable it per job or as a node-wide fallback.
How are the backup files named? Is it structured?
Yes. File names follow a format including template variables like cluster, guest name, node, node mid. Makes it easy to organize and identify backups.
And restoring a backup?
Via GUI, select backup, click restore, or command line, while PAC bear restore for containers, QM restore for VMs. You choose target node, storage, maybe a new guest ID.
Can you exclude specific files or directories from backups, like temp folders?
Yes, using the vzdump command line, you can use the exclude path option. Specify absolute paths, MNT data, or relative paths. TMP matches any subdir named TMP. Useful for excluding temp files or large data backed up separately.
How does Proxmox handle sending notifications about things like backup jobs completing or failing?
It has a flexible, configurable notification system. You can use this or a legacy email-only mode. The modern system is under data center notifications in the GUI, configured at its setupv notifications.cfg and its setupv prove notifications.cfg.
Let's dig into those notifications. What kinds of targets does it support? Where can alerts go?
Several options. Send mail uses the system SendMail. SMTP, direct to a mail relay. Hook script, run custom scripts on events, and integrations with services like Pushover and Telegram.
Okay, pretty flexible. How do you configure who gets notified and other details?
Each target type has specific properties. For email, SendMail SMTP, you set recipient addresses from address. For SMTP, you need server details, port, credentials, TLS settings.
What about sensitive info like passwords or API tokens?
Proxmox uses a secrets subnamespace. You reference them like secrets.mypushovertoken in the config. There are also helper functions for URL, encoding, escaping, JSON formatting within the configs.
Can you set up rules? Only get certain notifications or only at certain times?
Yes, using matchers. You can match based on calendar, weekdays, hours, specific fields in the notification data using exact match or regex, and severity level, info, notice, warning, error, unknown.
So you can filter alerts.
Right. Combine multiple matchers. Link matcher sets 2 targets. You also define notification policies, allow, deny, to control if a matching event actually gets sent to a target. Default is usually allow.
Proxmox VE has a comprehensive API and command line tools. How can you interact programmatically or from the terminal?
It exposes a full REST API over HTTPS, PV proxy, web UI, and Spice proxy listen for connections. By default on all IPs, but you can restrict this via listenip in etc. default PV proxy.
What about command line tools for direct interaction?
There's the Proxmox VE management shell, PVEsh. It lets you call API functions directly from the command line. Requires root privileges, though.
What can you do with PVEsh?
Retrieve info, PVEsh get nodes, check options, set configurations, PVEsh set cluster options, DAC console HTML5. It's basically direct API access via CLI.
Are there specific command line tools for managing storage, subs, Ceph, nodes, VMs, containers, etc., like dedicated tools?
Yes, absolutely. A whole suite.
Okay, let's hear them.
pfism is the storage manager. Add storage, manage props, scan. PV subscription manages subscription keys. pvceph manages Ceph service pools, OSDs, monitors. pvnode handles node tasks. ACME certs config.
Right. And for guests?
Kium manages QEMU server VMs, create, config, start, stop, status, migrate, move disk. pfix is the Proxmox container toolkit for LXC containers. Similar functions, create, config, start, stop, snapshot, restore.
Cluster and user management.
pvsmn manages the cluster, add, remove node, status, queue device. pvm manages users' permissions, realms, users' groups, ACLs, API tokens.
HA.
Hem manager manages HA resources groups, start, stop, add, set props.
Wow, okay, a tool for pretty much everything. Is there a central config file for data center-wide settings?
Yes, datacenter.cfg and etc PVE holds global options like max workers, background task limit, migration settings, network, security, registered tags definitions, tag style options.
Finally, the appendix mentions a Markdown primer. Why is that relevant to using Proxmox?
Because the web interface supports Markdown in various notes fields on nodes, VMs, containers.
Ah, for formatting the notes.
Exactly. It uses Common Mark with most GitHub-flavored Markdown GFM extensions, so you can use simple syntax for headings, bold, italics, lists, links, code blocks, even tables and task lists in those notes fields. Helps document things clearly right in the UI.
And there's also an appendix with the GNU free documentation license.
Appendix H, yeah. It contains the full text of the GFDL. That's the open source license for the Proxmox VE documentation itself.
Ah, so the docs are freely licensed too.
Exactly. Ensures the docs can be freely copied, distributed, modified, aligns with the overall open source philosophy.
So as you can see, Proxmox VE is, well, remarkably powerful and versatile, a true open source virtualization platform.
It really does integrate management, clustering, storage into a single cohesive system. It's quite impressive.
It really is surprising just how much depth and fine-grained control it offers. You know, from very low-level kernel configs all the way up to that pretty slick GUI.
And depending on your specific requirements, your interests, you can really focus on the areas that matter most. Scalability and HA. The clustering is key.
Right. Flexible software-defined storage, Ceph integration is huge.
Exactly. And for uptime, the HA features provide that solid foundation.
So considering this level of integration and how fast virtualization and containerization tech keeps moving, it really makes you wonder, what are some of the most innovative ways platforms like Proxmox VE might continue to evolve and converge these technologies in the future?
That is a fascinating thought to ponder. What's next for this kind of convergence?
Definitely something to think about. Thanks for joining us for this deep dive into Proxmox VE.